Derivative of a function. Consider the graph of a function, say f of x. Pick some point, say 3. Then this height is going to be f of 3. So the coordinates of this point are 3, f of 3. Now let's pick some point h units away. So this distance is h. So this point is 3 plus h. Then this height will be f of 3 plus h. So the coordinates of this point are 3 plus h, f of 3 plus h. If you want to find the slope of this line, so if I were to join these 2 points via a straight line, this is called secant line. So let's use a different color. So slope of this line will be, you can use the formula. So slope of secant line is the rise over run or the distance of y values, which is f of 3 plus h, that's y2, minus y1 is f of 3, divided by x2 minus x1, or this distance, which is h. So this is the slope of secant line. Now imagine that this point h is getting closer and closer to 0. In that case, this point is going to get closer and closer to the first point. So if the point has moved here, then your secant line will look something like that. And what happens if you take the limit as h approaches 0? So as h approaches 0, which means this gap is getting smaller and smaller, then the secant line will be approximated by the tangent line, at the point 3 comma f of 3. So if I take the limit as h approaches 0 of that slope of the secant line between 3 and 3 plus h, so which is f of 3 plus h minus f of 3 divided by h, this is going to be the slope of the tangent line at 3, and that's what we call as the derivative of f at 3. And we denote it by this notation, f prime of 3. Now I chose 3, but you could have picked any point in the domain. So when you write the derivative at x, you would say that the derivative at x is denoted by f prime x, and that will be equal to the limit as h approaches 0 of this fraction f of x plus h minus f of x divided by h. And that's what the definition of derivative is. So let's figure out some derivatives. Let's take a simple example. Say that function was x square. So if I want to figure out the derivative of f of x, then I would have to compute this limit. Now notice, I cannot plug h equal to 0 here, because if I do that, then I would get f of x minus f of x, which is 0 over 0. So in the video on limits, we said sometimes you could just plug h equal to 0 into your function, and sometimes you cannot. When you cannot, that means you have to do something with that function. Now this is a general definition. For this specific case where f of x is x square, f of x plus h is going to be the square of x plus h minus f of x is x square, and we will divide by h. So after this point, we will do some algebra. Denominator is just h, but notice x plus h quantity square is not x square plus h square, as you might already know. You would have to write x plus h times x plus h and multiply those two binomials, or FOIL. So it's when you do that, you get x square plus 2xh plus h square minus x square. Or if you remember the square of a binomial formula, you square the first term plus 2 times the product of those two terms plus square of the last term. That's the formula. X square plus 2xh plus h square minus x square. That's what I have in the numerator. Now notice this x square and minus x square, they can be combined. In fact, they cancel each other out. And what I'm left with is 2xh plus h square divided by h. And notice I have h appear in both terms, so I can factor out an h from each of the terms. Then I would have 2x here plus h over h. Oh, by the way, I forgot to write limit h approaches 0. So I'm not just doing the algebra, but finally I'll be taking the limit as h approaches 0. So I should have written that from the very beginning. So that's why I'm writing it now. And since h is not 0, it's approaching 0, but it's never 0. I can divide both numerator and denominator by h, or remove that common factor. Now notice, I can plug h equal to 0 at this point. Now I won't get 0 over 0. So when I plug h equal to 0, I get 2x plus 0, which is equal to 2x. So that's the derivative of x square that I have obtained by using the definition. Now, depending on what the function is, I may have to do some algebra, and that algebra could be simple or it could be tedious. Let's do one more example. Maybe this time we will use a trigonometric function. So let's say example 2, f of x equals, say, sine x. And if I want to find the derivative f prime x, this time I'll remember to write limit h approaches 0. And the denominator is just h, but the numerator, I have to evaluate the function at x plus h. So it would be sine of x plus h minus sine x. So now I have to figure out what the numerator simplifies to. So let me go ahead and write down as much as I can. Limit h approaches 0, and it's a fraction where the denominator is h. Now, if you know your trigonometric identities, you could write, so let me tell you one trigonometric identity. So sine of A minus sine B, you can write this as 2 cos of A plus B over 2 and sine of A minus B over 2. So we could use that. or you could expand this sine of x plus h first. But this way, I'm actually going to have only one term. It's the product of three factors, 2 and cosine of something times sine of something. So that way, this is going to be much better. So in this case, I would have 2 cosine of, look, I will be adding the angles and then dividing by 2. So if I add these angles, x, h, and x, I get 2x plus h divided by 2, and then sine of their difference, a minus b over 2. So now I have to subtract x plus h minus x is just h divided by 2. So this is coming from trigonometry. Sine of x plus h minus sine x is given by this expression. And again, now I have to recall a limit from a trigonometric limit. And that limit is limit theta approaches 0 of sine theta divided by theta is equal to 1. So this is a limit that we can prove, but I'm going to use this for this particular problem. So in that case, I can write my limit as limit h approaches 0. And what I'm going to do is I'm going to take this 2 and bring it down here. So that way I have cosine of 2x plus h over 2 sine of h over 2 divided by h over 2. So now one of the things I can do with limits is I can separate these two functions and write this as cosine of 2x plus h divided by 2, and then limit h approaches 0 of the remaining part, which is sine of h over 2 divided by h over 2. Now notice this turns out to be 1 because when h approaches 0, h over 2 also approaches 0. So I could write this as h over 2 approaches 0, and then I could use this limit. So all of that is just 1. So I'm only going to have this particular function or this particular limit. And now if I plug h equal to 0, I would have cosine of 2x over 2, which is just cosine of x. So that's the answer for the derivative of sine x. Now, we did one problem where it was just x square. That was easy because it was coming from algebra. We just had to FOIL. Now here we used two powerful tools. One is a trigonometric identity to combine these two signs into one. And then we also used this particular limit, which we have not proved, but we trusted that it is true. And then we realized the fact that h approaches 0 is equivalent to saying h over 2 approaches 0. So the derivative of sine x is cosine x. Now we'll look at more derivatives and we will develop some formulas. That way we don't have to always use the definition of derivative in future. And that's all will be in future videos. Until then, I'll see you. Thank you.